This is Mr. Beck Does Your Homework, AP Physics, Homework 8.4, question number 10. In a nuclear power plant, the reactor produces 420 degrees Celsius steam that is used to power the steam turbines, which generate 2,703 megawatts of electrical power. The cooling tower eliminates the waste heat at 58 degrees Celsius. So I have two temperatures here. My T hot is 420 degrees Celsius, and my T cold is going to be 58 degrees Celsius. Before I do anything, I really should add 273 to each one of those in order to turn it into Kelvin. So I will have a T hot in Kelvin, and I will have a T cold in Kelvin because I have to use absolute temperatures. The power is 2,703 megawatts of electrical power, so that's good stuff. So I've got a cycle here that I'm going to take some in, I'm going to do my cycle, I'm going to lose some, and I'm going to do some over here. This one is the work that I get out, but this is watts. So this is joules per second. This is millions of joules per second. So what I'm going to do is I'm going to look at this entire cycle in terms of not what happens in one cycle, but what happens in 1 second. And all of my work, all of my numbers should still be the same. So this is my work out is 2703 megajoules per second. So this is my work out per second. Is 2,703 megajoules, millions of joules per second. The efficiency is that of a Carnot engine. At what rate is waste heat vented to the atmosphere? So what I'm looking for is my Q out per second. So I want my Q out per second. So if this is per second, then I can do this per second, and it's going to work. The efficiency is that of a Carnot engine. So I know that my efficiency is going to be my temperature hot minus my temperature cold divided by my temperature hot. Here's my temperature hot, here's my temperature cold. Do this and you will get yourself the efficiency of your cycle. You know that this represents how efficient it is. So this tells you, it would tell me that my work out, and this is per second, is going to equal my efficiency times my Q in per second. So I'm just doing it per second because this is in watts instead of joules. So if I figured out my efficiency, there it is. So if I divide my work by my efficiency, I'll get my Q in. And then I know that my Q out, again per second, is going to be my, we'll just say 1 minus my efficiency. It's my inefficiency times my Q in, again per second. So if my efficiency were 20%, my inefficiency would be 80%. If my efficiency were 5%, my inefficiency would be 95%. So your Q out represents your inefficiency. It's how bad your system is. So the bigger this one gets, the smaller this one gets. So you can get your efficiency. Let's say it's 22%. Then this would be 1 minus 22%, 1 minus 0.22, this would be 0.78. So whatever you get for your efficiency, 1 minus it, and get a smaller number that would add up to 100%. And that decimal times your Q in will give you your Q out, and that's what it's looking for. Answering units of megawatts. If you leave this as megajoules per second, you'll get this in megajoules per second, which is megawatts. So you really don't have to convert this into times 10 to the 6th because you're dealing with megawatts on the way out.